Hi, glad to have you all here, and I'm pleased to introduce our speaker, Colleen Dai, who's going to discuss Semgrep.
Hi, thanks for the introduction. I'm Colleen, and today I'll be talking about enforcing code and security standards with a tool called Semgrep. So sometimes you might want to identify some specific patterns in your code for either security purposes or for coding best practice. And you might think about using grep, but grep often gives you a lot of noisy results because it doesn't actually fully understand code. So I'm just going to talk about what we've been working on, a tool called Semgrep that makes writing custom rules pretty easy and makes your search a lot less noisy. So Semgrep is actually a static analysis tool, and static analysis just involves programs analyzing your source code. So here's a quick TLDW of this talk. So essentially, writing secure code is pretty difficult, and so is adhering to coding best practices. And sometimes static analysis tools are a little bit too noisy or too slow. On the other hand, grep oftentimes isn't expressive enough to do exactly what you want with it. And you might need something that's fast, code-aware, flexible, and open source. So let me just introduce Semgrep, which is a fast and syntax-aware semantic code pattern search for a lot of languages. So you can think of it as a code-aware grep. And what do we use Semgrep for? Well, we use it to find some security bugs, guard and enforce specific patterns and best practices, and also easily upgrade from deprecated APIs. So we have used Semgrep to find some bugs in open repositories. So if you go to our docs link, which I'll show later, you can find a listing of all the bugs that we've caught. So feel free to check that out. And later in this presentation, I'll introduce you guys to essentially how we detect bugs in mass. So who am I? My name is Colleen, and I'm currently a security software engineer at R2C. I graduated Stanford with my bachelor's of CS and my master's in statistics. And so what's R2C? Well, we're an SF-based static analysis startup, and our mission is to profoundly improve software security and reliability. Cool, so here's a brief outline of what we'll be talking about today. So I'll first introduce the background of Semgrep, and then we can talk a little bit about grep and abstract syntax trees. And then we'll talk about some examples and give an overview of how Semgrep works, and then talk about going hunting with Semgrep. After that, we'll talk about integration into CI/CD, and then we'll talk about the rules registry. So Semgrep is an open source tool and it has a long history of being open source. So feel free to check it out on this GitHub page. The first version of Semgrep was actually written at Facebook around 2009, and it was used to enforce around like 1,000 rules. The original author, Johan, actually joined R2C last year, and he was the first static analysis hire at Facebook and got his PhD at Embria. He is also a contributor to Coccinelle, which is used for Linux kernel refactoring, and it's used to match and transform C code. So we have support for a handful of languages, and we just released TypeScript and PHP, so keep an eye out for those. Also in the works are Kotlin and C#, but we might not be porting those until next year. Awesome, so now that we've talked a little bit about the backgrounds, let's delve into grep and abstract syntax trees. So let's imagine some situation where we have a code base that consists of this code, and we want to find a specific snippet of code. So we might turn to regular expressions in grep, which makes a lot of sense because they're super great for rapidly searching through text or patterns. So let's look at this code over here and see what we would want to match, right? So if we're trying to find calls to exec, because exec calls are normally dangerous in a lot of cases, then we would want to match these first 4 cases, right? Because they are calls to exec. We would also want to match this case over here, other exec food, because it is basically just another exec call. But we wouldn't want to match this comment over here. And we wouldn't want to match this string literal where we're just printing exec bar. So how do we do this using regexes? Well, if we want to match these first two cases, it would be pretty easy. We could just do exec backslash parentheses. Over here, these next two cases are a little bit more difficult because there's a bunch of white space and new lines. So you would have to do /s star or /n star in order to capture all the new lines. Over here, it's also pretty hard because you would have to find any method suffix that matches exec. And over here, it's even harder because grep doesn't know exactly which part of your code is a comment, and it also doesn't know which part of your code is a string literal. So it'll catch these two cases over here, probably no matter what. And as we can now see, sometimes using regexes on our code turns out to be a pretty large headache just because it can't fully understand your code. So why are regexes unable to understand your code? Well, the issue is that code is a string. It's not a string, it's a tree. So if you remember way back to your programming or programming languages or compilers classes, code actually gets parsed into an abstract syntax tree, or AST, as you can see on the right. So in short, the difference between Semgrep and grep is that Semgrep lets you actually search your code at AST level, not the string level. So essentially, Semgrep knows when something's a comment, a string literal, or a function call. And therefore, it can more easily catch the functions, the calls to exec that we saw before. And there's also a lot of AST matching tools, one of which is ESLint. So you might think about writing your own AST matching tool, which is fun and a very potentially big project. But this has quite a high barrier to entry, right? Because every language has a different grammar, which results in a different AST. So if you want to write an AST matching tool for a certain project that uses multiple languages, you would have to write this AST matching tool for every single language because every single language has a unique AST. So this becomes quite time consuming and needs a bit of programming language expertise. So you might, on the other hand, think about using some commercial static analysis tools, but these tend to be pretty complicated, slow, and cost a lot of money. So on the right, we see that this is actually some code from ESLint that basically discovers your eval calls, and it is 307 lines of code, which is quite a lot of code to find some calls to eval. And Instagram actually published a pretty insightful article last year with this graphic that shows the static analysis spectrum. So on the left, we have some regexes, which are pretty easy but limited in their use cases. And on the right, we have whole program analysis, which is pretty powerful but complex. So whole program analysis tools aren't easy to customize and often take a lot of time. And whole program analysis basically tracks data flow and traces user input from its source to its endpoints. So where does Semgrep sit? Well, Semgrep sits somewhere in the middle. So it provides a pretty easy interface to match tree representations of code. And Semgrep also operates on files, so it doesn't match the whole program, but this also makes it pretty speedy compared to whole program analysis tools. And I'd say that Semgrep's key insight is that it lets you reason about your analysis the way you reason about your code. And if you want to read more about this, feel free to click on this link and go to the blog post that inspired it. Awesome. I guess I'll stop here for now and ask for questions. Feel free to ask me questions if anyone has any.
Great so far.
Okay, awesome.
Nothing else.
Let's move on to talk a little bit about some Semgrep examples then. So let's go through essentially 4 topics. And I'm going to be showing you how to use Semgrep essentially. So we'll start with a quick overview of how to use it and then explore some interesting uses and advanced features. So Semgrep patterns are essentially just the source code you're targeting, unlike a lot of other AST-based tools where you have to learn another new language. So when you're trying to search JavaScript code or Go code, you're just going to write patterns that are mostly just JavaScript or Go. But there's two pretty helpful abstractions that we call the ellipses operator and meta variables. So we're going to be giving an example of each in this tutorial. So as a note, Semgrep can be run in the command line interface through pip, brew, or docker, but we're going to be using semgrep.dev in this talk, which is an online editor. Cool, so let's first look at the ellipses operator. And the ellipses essentially abstracts away sequences of things. So these things could be arguments, could be parameters, or even entire statements. So you can think of it as the dot star in regexes. So let's consider the case that there's a function you know you don't want to be used. It might be insecure, pretty outdated, or not supported anymore. So a good example of such a function is the nodeexec function. And this function could lead to command injection if there's any user input passed into the function itself. So let's look at this code and try to write a pattern to match all these exec calls. And we see that's the exact same code that we saw before. So we know that we want to match these 4 cases, but we don't want to match these lower 2 cases. Cool, so let's first copy and paste this first line to see exactly what it does. And we see that it matches the exact first line, right, as we expect it to. So we don't really care about what argument we pass into exec call, right, because we want to match every exec call. So we can abstract away this argument that's passed in with the ellipses operator. And let's see what this does. Awesome. So we see that it matches exactly what we expect it to match, but it doesn't match the comment or the string literal, right? Because Semgrep is code aware, and therefore it knows that this is a comment and knows that this is a string literal, so it won't match on those. Awesome. So now let's look at another case where we can use the ellipses. So let's consider this case in which we don't want private information to be revealed in public repositories. So if we expose our AWS secrets to the public by writing or pushing this code to a public repository, this can lead to breaches, to people being able to get into your AWS account, etc. So let's write a pattern to catch these accidental pushes. Cool, so we see over here that essentially we're calling b3.client with AWS access key ID equal to some const, which is defined over here as a constant. And same thing with some other const, right? We're defining this as a constant over here. And over here, we're still hard coding this into our file because we're just, instead of saying some other const that equals a string literal, we're just having a string literal right over here. So because Semgrep patterns are essentially like the code you're writing, we're just going to do some nice copy and pasting. So another good thing to note is that essentially Semgrep knows that we're importing Boto3 as B3. So instead of B3 over here, we're going to write Boto3. And essentially we want to check that AWS access key ID equals a string literal. So in order to represent any string literal, I'm going to use the ellipses that is surrounded by double quotes. And this just represents any string literal. And we're going to do the same thing for the AWS secret access key. So let's run this pattern and see what happens. We see that we're matching both of these cases, even though this is not directly a string literal, because Semgrep does something called constant propagation, which actually basically propagates constants down to when they're used. And therefore it knows that this const over here is actually a string literal. Another good thing to notice is that over here we see the parameters are swapped. AWS secret access key is first, and then AWS access key ID is second. The opposite way of which we sort of wrote this pattern. But Semgrep still captures this because order doesn't matter in its patterns. Awesome. So now that we've talked a little bit about the ellipses operator, I'm going to introduce something called meta variables. And you can think of meta variables sort of like capture groups and regexes. So sometimes you don't know exactly what you're matching, but you want to grab a reference to it later in order to use it later or reference it. So in this case, there's a package that we don't want to be using, the unsafe package. So unsafe actually opts out of memory safety in type safety in Go programs, and this can lead to memory vulnerabilities. So let's try to find all function calls from the unsafe package. And unsafe has a pretty large number of functions, and we could probably write a pattern for each one like we did for eval, but that's sort of a pain. So in this example, instead of writing an individual pattern for each function of the package, we're going to be using a meta variable as a stand-in for function calls. And I'll show you how to do this in this example. So if we take a brief look at the test code, we see that we're calling unsafe.pointer and unsafe.sizeof over here. And then here's another call to unsafe.pointer. And we want to capture all of these calls from the unsafe package. So as usual, let's do some copy and pasting. And let's do what we did with the eval call. We don't really care about the arguments, so we're going to abstract that away with the ellipses operator. And we could just tag all these function calls to pointer, right? But we want to capture instead also the function calls to sizeof. And essentially, we can abstract the name of this function away with meta variables. And to create a meta variable, you just need a $, and then you can name the meta variable whatever you want. So I'm just going to name the meta variable, in this case, func, because it represents a function. So let's see what this does. Awesome. So we see that we're also capturing unsafe.sizeof in this case. And a good thing to note is that meta variables itself that have the same name represent the same meta variable or variable. So essentially, if we're going to use func again, it represents the same thing that it caught in the beginning. So let's combine what we've learned with the ellipses in the meta variables. So we might want to detect some path traversal in our code. So for example, there is a path traversal vulnerability in this function because the file name over here is passed into the send file function. And because file name is user controlled, essentially the user can try to open any file in the server's file system. And this is not good. This is not the output that we want. So essentially, let's try to capture code that is vulnerable to these path traversal vulnerabilities. So let's do our favorite thing, which is copy and paste. And let's see how we can generalize this code over here to get a pretty good pattern that will capture these path traversal file injection vulnerabilities. So we don't really care what the route itself is. So we're going to abstract that away with the ellipses, the dot, dot, dot. And we also don't really care what the name of this function is. So we're going to abstract that away with our meta variable. And file name itself could be named anything. It could be named fname. It could be named file. We don't really care what's named. So let's, again, abstract that away with file name, a meta variable. So we also don't really care what's in between the function definition over here and the function return. So we're going to abstract that away with the ellipses. And what we really care about is that this user-defined input file name is also passed into send file function. And because, as I was saying before, file name, a meta variable is the same if you name it the same. So it represents the same variable if you name it the same thing. We're going to check that the user input is passed into send file with this. We also don't really care if as attachment is true or false, or other parameters are passed into the send file call. So we can abstract that away with the ellipses again. Also, another last thing to note is that because we're importing send file from Flask, we want to say that it is a flask.send file call. So essentially, let's see what this pattern catches. And it's awesome. It seems that we're getting exactly what we wanted to catch, this path traversal vulnerability that we saw on the slide. Awesome. So that's an example of combining the ellipses and metavariable operators that we saw and learned about. Cool. Is there any questions on ellipses or metavariables? Okay, cool. Let's move on to composing patterns. So sometimes we might want to do something a little bit more complicated than just find one specific pattern. We might want to find some code where A and B occurs, or A and not B occurs, or A or B occurs. Essentially, we might want to combine these pattern clauses. So Semgrep actually provides a pretty easy way to do combinations like this. And I'll show you how to do this with the following example. So let's say we want to enforce another security default. And essentially, we know that we want to set cookies. But when we set cookies, usually the default doesn't set them securely. So we want to use some secure headers like HTTP only, which protects the cookie from being read with JavaScript, and secure, which limits the cookies to HTTPS traffic only. So we want to sort of harden whenever we set our cookies to make sure that we add in these secure headers. And let's try to use Semgrep to detect some cookies that don't follow these security hardening principles and don't have the HTTP only or secure headers. So let's take a bit of a look at the example code we have here. So over here, we see we're sending cookie with username and Drew, and this is not secure, right? Because it doesn't have those secure headers we talked about. Over here, the same problem. In fact, we're actively setting secure equals false, which is not ideal. And over here, we have a comment, so we don't really care about this. But on this last line, we see that we are setting a secure cookie because we're setting secure equals true and HTTP only equals true. So what do we want to match on? We want to match on this first case, right? This second case because it's also insecure, but we don't want to match on this last case because we're setting it correctly with all the secure headers. So first, let's just try to use a general pattern and capture all the places where we set cookies. So we're going to, again, abstract away our arguments with the ellipses operator. So we're going to use the ... And instead of using R, because we're importing R as response from Flask, we're going to say flask.response instead. So let's see what this does. Awesome. So we see that this actually captures all three of these cookies, even though this one is secure, because we haven't explicitly said that we don't want to capture cases where secure equals true and HTTP only equals true. So in order to specify there that we don't want to capture cases where secure equals true and HTTP only equals true, we're going to use this and is not pattern clause. So we're going to, copy and paste as usual. And we don't really care where secure equals true, HTTP only equals true is placed in the set cookie function. So we're going to use ellipses to sort of abstract away the fact that we don't really care what the order is. We don't really care what's on the left of secure equals true, HTTP only equals true, and we don't really care what's on the right either. So we're going to have ellipses surrounding this, and we're going to place secure equals true and HTTP only equals true in the middle. And let's see what this does. Awesome. So we see that over here, we're excluding this secure cookie. And this really helps in preventing a lot of false positives when you're trying to match a certain pattern. Awesome. So let's talk about finding insecure SSL configurations. So you might want to think about also hardening your SSL configurations, not just your cookie headers. So essentially, we want to make sure that our TLS configurations are pretty secure. And this configuration over here in particular is not great because there's two things that catch my eye. We're setting insecure skip verify to true. And this actually is not secure because it does not verify the validity of certificates shown by client users. So this makes HTTPS connections insecure and vulnerable to man-in-the-middle attacks. And same with minimum version TLS version SSL 3.0. This minimum version SSL 3.0 has known crypto attacks against it, and it's therefore not secure to use. You probably want to use TLS versions that are cryptographically secure, and SSL 3.0 is definitely not. So we wanted to detect these cases where these SSL configurations are insecure. So let's do that in this example. So over here, we see that we have two configuration objects. One is over here, and this one has minimum version TLS version SSL 3.0 set to true, set to 3.0, and insecure skip verify set to true. And this is also not great either because we still have insecure skip verify equal to true, even though the min version is a little bit better. So in order to capture both of these cases, we want to capture cases where the min version is version SSL 3.0 or insecure skip verify is equal to true. And we can do this with something called pattern either. So essentially we can go to this advanced pattern, which is basically just YAML. The simple editor over here lets you do some more things, but it's basically just converts your patterns to YAML. So this is just some fun YAML that we can tackle. So we want to capture cases where essentially this configuration object has sets TLS version SSL 3.0, or it has sets insecure skip verify to true. So we're just going to copy and paste this pattern instead of min version, we want to capture the insecure skip verify. And I think I miscopied the I. So let's see what this does. And we see now that we're capturing both of these cases because of this pattern either. So it's just a ORing of these two patterns. Awesome. So now that we've talked about composing patterns, we can talk about some more advanced features. And does anyone have any questions right now?
Hi, Colleen. My name is Felipe. I have a question.
Yes, for sure.
Thank you. Well, first, thanks for the talk. Really helpful. So I have a question in your previous query or the set cookie in Flask.
Mm-hmm.
So let's say that the set cookie function has default values for secure and HTTP only. And those are true. Let's say the default value would be true. So would we have a match in the first in the first set cookie call? There?
Right. So if the default values were true, you would still have a match because you're essentially just searching for r.set cookie with any parameters. But if the secure defaults were true, then we wouldn't want to write a pattern to match this set cookie anyways, right? Because the secure defaults are always true. We just want to write this pattern in cases where the defaults are insecure, which is a lot of places in code sometimes. But yeah, that's a great question. So I guess the answer for that question would be, yes, we would still catch those cases in which the defaults were secure, but we wouldn't want to match a pattern in those or write a pattern in those cases because the defaults are secure anyways. Does that sort of make sense?
Yeah, sure. Thank you. Yeah, we could write a query if the value is false then, and instead of checking true. Okay, yeah,
right,
that makes
exactly.
sense. Mm-hmm. Thank you very much.
Yes, for sure. Awesome. Now let's talk about some more advanced features. So although we use Semgrep in a lot of times to sort of enforce our security defaults and security standards, it doesn't need to just be used for security cases. It can also be used to enforce some specific types of business logic. So in this case of using Semgrep for business logic, there's these cases in which we might want to enforce the order of API calls in general. So this might be because in some cases, one API call first sets up some global states or actually verifies the data inside some object. So in this example, let's take a look at a hypothetical financial trading application. And in this hypothetical trading application, a transaction has to be verified before it's made. So let's look at this pattern over here to check out essentially what we're matching and what we're not. So there's a few examples in which we're calling make transaction, and we see that this example in particular is okay because we're verifying the transaction before we're making it. This is not good because we're just making the transaction without verification. And this is also not good because we're verifying it after we make it, which is not exactly useful. So this over here is okay because we're just verifying transaction and not making it. This is bad because we're making it and then verifying it. And these are all okay, right? Because we're verifying the transaction before making it. But this, on the other hand, is bad because we're verifying transaction other and making transaction T. But we haven't caught this with this pattern that we're using over here. And let's look at why we're not catching this. So let's first look at this main pattern. And in this, we're just matching any method that calls make transaction. This second pattern, we're trying to filter out cases where verify transaction is called before make transaction. But we also want to specify that the transaction that's verified is the same as the transaction that's made. So in order to represent the verified transaction, let's use a meta variable. And we can just call this meta variable T. So let's do that. On the other hand, we want to make sure that our transaction that's made is the same as the transaction that's verified. So we just need to make sure that the transaction that's made is meta variable T. And now let's run this. And we see that we're matching this bad case. So this is pretty useful because as we have talked about before, meta variables essentially represent the same variable or object. And this makes it pretty easy to filter out to make sure that verified transactions are the same transactions that are being made. Awesome. So we've been focusing on sort of detecting issues, but it'd be nice if our tools don't just point out our problems, but also help us fix them. So Semgrep supports the ability to not just find a pattern, but also enter a fix for the problem, which you can then easily apply. So this is pretty useful for migrating off of deprecated APIs or fixing insecure settings. So in this example, we're again looking at the SSL configuration example, and we want to make sure that our TLS version that we are using is the latest version. So we can use this feature called autofix, where you can specify a regex that you want to replace and the replacement. And then over here, we see that essentially we're matching on one case. And there's this autofix suggestion that we have. So we can say, apply this fix to this match over here. And currently it says SSL 3.0, but if we apply the fix, it'll say TLS 1.3. And this is quite easy to just go through your code and replace the bad version with the good version. And essentially, this is pretty versatile, so you can specify the regex that you want to match and the replacement regex. Awesome. So Semgrep has another useful feature that lets you use regexes to capture some specific types of strings. So I'll demonstrate this functionality with this example. So in this case, we want to use we want to protect essentially the data we're sending over a network. And we want to make sure that we're sending HTTPS requests and not HTTP requests. And this is because HTTP does not use TLS, and therefore our requested data might be passed in plain text and be pretty vulnerable to man-in-the-middle attacks. So let's see how we can sort of match this using string regexes. So over here, we see that we're looking for a new request that has some HTTP URL in it. And essentially, we can use regexes, which are PCRE regexes, and to match only HTTP strings and not HTTPS strings. So we see that we're matching the HTTP example.com, but not matching HTTPS example.com. So this is pretty useful, and you can use it to detect cases where you're requesting for FTP instead of SFTP, telnet instead of SSH, etc. So another case in which Semgrep might be useful is for getting visibility into your code. So let's say we want to find all the routes in our codes to know essentially exactly what API endpoints we have and exactly essentially what routes we have. And Semgrep can pretty easily do this with this pattern. And this pattern in particular is for Go Gorilla routes. So essentially we're capturing all the routes, their handler functions, and also the HTTP verb. And we're printing all these routes, their handlers, and the HTTP verb over here. So if we want to, in particular, only get routes, we can specify get over here. Same with post routes, put routes, delete routes, etc. So you can either keep track of a specific kind of route, or you can just grab all your routes in general. So this is a visualization that we've built on top of route detection that we think is pretty cool. So we've used this in security audits of code bases, and we've also used Semgrep to extract information and visualize routes with D3. So it's just a pretty nice overview of what routes you have and essentially what type of routes you have. So another pretty cool feature we introduced pretty recently is generic language support. So this means you can search for patterns in YAML configurations and Terraform configurations. So in this example, we're going to be trying to detect cases where we have public read-write access control lists. And this is pretty dangerous because we don't want the public to be able to read or write our data. So in order to detect this, we have this pattern over here. And the pattern is this. And we can see that there's a bunch of spaces over here, but we're still detecting the ACL equals public read-write. So you can use this to detect your Docker configurations or errors in your YAML configurations, etc. So it's quite useful. We also have a bunch of docs. So feel free to check out our pattern syntax or anything essentially on our docs. Awesome. Any questions currently about what we've talked about? Okay, awesome. Since there's no questions, let's talk about going hunting. And essentially, we've talked a lot about how to enforce secure defaults and adhere to some good security practices, but we might be more interested in finding vulnerabilities and bug hunting instead. So from the examples we did before, we can see how we might use Semgrep to scan for vulnerabilities. And let me just demonstrate briefly how to use Semgrep internally to find vulnerabilities. We also vet our rules in this manner over a lot of open source repositories. So let's take a closer look at this pattern and what it's trying to do. It seems really similar to one of the patterns that we've written before, but let's just take a brief look. So essentially, we're looking for flash routes that use a user passed in inputs to open a file, right? And essentially, this expression over here is something we call the deep expression operator, which tells Semgrep that file name can appear in any expression in that first argument to open. So file name might be concatenated to another string or part of an os.path.join, and Semgrep will still detect that a pattern is valid. So let's take a look over here. And essentially, we see that we're matching this path traversal vulnerability. Essentially, because file name is os.path.join to temp, and we're using the deep expression operator, it will still capture this statement over here. So how do we sort of test this rule on a bunch of repositories? Well, we have a MapReduce platform called Massive Analysis Platform, and essentially you just specify the analyzer, which is subgrep, that you want to use, and then select your input set that you can create by yourself or use some of our already created input sets. And in this case, we've chosen the top 1,000 Flask applications on GitHub. And then we can just run this job and essentially just run this rule on thousands of GitHub repositories. So after we run this rule, we get a bunch of results, and we can click on this action in order to see the exact code that Semgrep matched. And if we opened up to click this, we could see that we matched this actual patch reversal vulnerability. And that is how we sort of get our CVEs, and also how we vet our rules. Cool, any questions on this? Okay, now let's talk about integration into CI/CD. So we might want to enforce some secure defaults and secure frameworks at CI time. So it's pretty easy to add Semgrep to your CI as either a Docker container or Linux binary. It also has JSON inputs, which makes it pretty easy to integrate with other systems. And we have a bunch of predefined YAML syntax for your CI, and we have it for GitHub, GitLab, CircleCI, Travis, AppFair. So this is Semgrep running as a GitHub action on one of our Flask applications, and it actually detected a patch reversal. If you look at the rule that ran over here. So this is pretty cool. And essentially, if we go onto dev, semgrep.dev, oh, not Sentry. Essentially, if we go onto semgrep.dev and we want to write a specific rule, we can share this rule and look at the CI uses. And if we want to use this rule in our CI, we can just copy and paste this YAML code. So now that we've talked a little bit about CI/CD, let's talk about the rules registry. So we have a community rules registry. So if you think that Semgrep sounds nice, but you might be super busy and don't have time to write a bunch of rules, there's a lot of pre-written rules that you can just get out of the box. So we have, I think, over 900 rules by the R2C community. And we have community contributors, including Node.js Scan, Damien, who's the author of the Go Perf book, a few OAuths contributors, and potentially you. And we've also organized our rules into sets. So we have the cross-site scripting set, the JWT set, and some insecure transport sets. So feel free to check that out. And you can pretty easily run the rules in the community registry by just running semgrep-config equals the URL to the rule pack. And all the rules are essentially in our semgrep.rules repository, so feel free to check that out too. And this is basically an overview of the Explore tab for Semgrep. And essentially that you can sort of look at the rule packs for getting started. You can look at rule packs for code quality and our ported security tool rules. If you want to check out individual rules, for instance, if you want to check out crypto rules or MD5 rules, feel free to look at our registry. It takes a little bit to load, but essentially you're able to look for specific rules. And if you want to look for XSS rules, you can do so. If you want to look for MD5 rules, you can also do so. So feel free to check that out. And you can specify your languages and also the categories that you want to check. So what are we currently doing? Well, we're improving our language support and trying to port new languages. So next on our board are Kotlin and C#. We're also working on more rules and some prevention cheat sheets. Furthermore, we're looking at Semgrep community and how to sort of let you centrally manage Semgrep on all your repositories. So over here, we can see just a brief overview of Semgrep community, and you can specify that you're blocking CI or just notifying for a few of your rules. We also have a VS Code extension, and we're working on tainting and concept propagation. So concept propagation we looked at before. It's a process of substituting known constants into expressions at compile time. And tainting is essentially this technique where you track user input sources and trace those sources flow throughout your program. Awesome. So for wrapping up, that's my talk. So it's really easy to get started with Semgrep. You can just brew or pip install it, or you can try it on the online live editor. It's also available as a Docker container if you want to try that out. And please consider taking this survey over here if you have any comments. We really, really want to know what you think. So any questions?
I'm glad to have gotten